Good evening, my name's Jordan Maltby, and first off I'd like to apologise for having to wear this headset. I just wanted to get my sound a little bit more clear for you guys. I study engineering at Central Queensland University Bundaberg, and I'm going to walk you through the understanding application of Kirchhoff's laws. First off, we need to understand two basic laws of electrical circuits, the first of which being law of conservation of energy. So the total amount of energy in an isolated system remains constant over time. The second law is Ohm's law. The current in a resistive circuit is directly proportional to its applied voltage and inversely proportional to the resistance, so V equals IR. Kirchhoff's first law is his law of current. This law states that the sum of currents entering any node equals the sum of currents leaving that node, and a node is any junction of wires. So algebraically it might look like this, or you may have seen it in a textbook as I1 equals I2 plus I3 plus ... Kirchhoff's second law is his law of voltage, and it states that the algebraic sum of all voltages in a loop must equal zero. Algebraically it looks like this. Let's have a go at applying it in a qualitative example. So the sum of the voltages in a loop equals zero. Here we have a battery and three resistors all in series. So we know that the voltage gain here is going to equal the voltage drop across the sum of all resistors. In our second example, we'll have a look at Kirchhoff's voltage law for a parallel circuit. Here we have a battery cell in parallel with two resistors, which are both in parallel to each other. So first off, we need to consider one loop. We'll consider the smaller loop of ABCFA. In this loop, we have a voltage gain from the battery and a voltage drop from the resistor. We know that from Kirchhoff's voltage law, they're going to be the same value. Similarly, you'll get the same answer for the wider loop. And pretty much if you put a voltmeter on a parallel circuit like this in real life, you'd get the same reading. So say the battery was 2 volts, you get 2 volts roughly over the resistor and 2 volts over the second resistor. So Kirchhoff's current law in this example tells us that the current entering the node is I1 and the currents leaving the node is I2 and I3. So the sum of these is I1 is equal to I2 plus I3. In this example we have two currents entering the node and one current leaving the node. So I1 is plus I2 is equal to I3. Let's have a go at applying it to a real problem. So here we have, similar to before, a parallel circuit of two resistors and a battery. We know the voltage across the battery is 2 volts, and so the voltage across both resistors is also 2 volts. From Kirchhoff's current law, we know that I1 is equal to the sum of I2 and I3, which equals 1 amp. We also know that the resistance value of resistor 1 is 10 ohms. So let's use these to find the resistance value of the second resistor. So we'll start off with Ohm's law and we'll find I2. We know what the voltage is across this resistor and the resistor value. So let's find the current. V equals IR. Rearrange for I, you get I equals 2 over 10, which is 0.2 amps. Then we're going to use Kirchhoff's current law to find I3. I1 equals I2 plus I3. I1 is 1, I2 is 0.2, so I3 must equal 0.8 amps. Now that we have the current traveling through this resistor and the voltage across this resistor, we can find out the resistor's value of resistance. So V equals IR again, rearrange for resistance this time, which is voltage over current, 2 over 0.8, and you'll equate that to 2.5 ohms. Therefore, we used Ohm's law and Kirchhoff's law of voltage and current to easily find the resistance of this resistor. You'll use these laws most commonly in electrical engineering, and electrical engineers use these to analyze circuits. It's the starting of their basic understanding when they're looking at electrical circuits. So it's part of the fundamental principles that you'll learn most likely in high school and also at the start of your university course. I hope you learned everything you needed today about Kirchhoff's laws. If you have any questions or if I missed anything out, please post in the comments below. Thanks.